In this video, I'm going to show you how to take this funny looking graph and transform it. We're going to stretch it, move it left and right, and so on. And I'm going to call this green graph my parent function because it's kind of my starting function. And you should notice that there's not one specific equation that can describe this graph because it's kind of broken up into 4 segments. So what I'm going to do is I'm just going to name this function. I'm going to refer to this function as f at x. This will make more sense as we move through the video. And this is function notation. And this means f at x, not f times x. So I'm calling this graph here f at x. Now let's say I want to take this graph and I want to vertically stretch on it, kind of pull up on it and pull down on it in the vertical direction, the up and down direction, which would make it appear to be skinnier. What can I do with this f of x to indicate that? Well, hopefully you remember that when you want to do a vertical stretch, you need to multiply by some number greater than 1. So how about if I multiply this f of x by 2, like this? I'll go 2 times f at x. And this multiplication by 2 will cause this graph to vertically stretch. So let me kind of show you how I go about this. First, I'm going to include some extra points in here at the corners. Just put those in there so you can see them. And you need to understand that this notation means the following. It means to take 2 times the y value. So basically, I'm taking the y value times 2. That's what this means. So let's find the y value of this point and multiply it by 2, and then we'll continue that process. So what's the y value here? Remember, my y values are this way, up and down. The y value is 1. What's 1 times 2? From right here, times 2. 1 times 2 is 2. So this stretches up to a 2, right here, right over here. Now, one thing I want to point out is when I'm doing this, I always read my graph from left to right. So I start at my farthest left point, then I move to my next farthest left point, which is here. What's the y value here? It's right over here. It's negative 3. Negative 3 times 2 is negative 6. So this vertically stretches down to a negative 6 right here. Okay, let's go to this point. This value is 2, the y value. I'm going to multiply that by 2. 2 times 2 is 4. So this stretches to a 4 right here. All right, let's go to this point. What's the y value here? It's 0. What's 0 times 2? Well, that's 0. So this y value just stays at 0. This stays put. And you should notice here the y values are the things that are changing, not the x values. This particular y value stayed put because we multiplied it by 0. What about this one? This y value is 2. What's 2 times 2? That's 4. So this stretches up to a 4 right over here. And now let's make our new transformed graph. I'll get it as good as I can. Remember, I'm connecting the points from left to right. And the new graph was vertically stretched. It appears skinnier. So let's make sure we're clear on this. F of x represents the green graph. And when I multiply the f of x times 2, it vertically stretches it by a factor of 2, which is the purple graph right here. So I hope you're clear on that. Let's do a couple more examples. Let's say instead of vertically stretching the graph, I wanted to move the graph left or right. I want to do a horizontal movement. So let's say I wanted to move this graph to the right 2 units, everything to the right 2 units. How would I change this f of x notation? Again, this is tricky, especially if you're just first learning it. Here's how I would do it. I'd bring down my f, and I'd replace the x with x minus 2. This x minus 2 is going to shift everything to the right 2. You would think it's to the left 2, but in previous videos, I explained why that would be to the right 2. So let's think about this. You should know that this is a left-right movement, a horizontal movement, because the minus 2 is attached to the x, and the x goes this way. You just got to remember that it's going to move it in the opposite direction that you think. So when it's written in this notation, it's going to cause each value to move right 2 units. So let's do that. I'll move this right 2 units. And remember, I always read my graph from left to right. So let's move this left 2 units, 1, 2. I'll just continue to move each point 2 units to the, did I say to the left? I meant to the right. Let me start that over. Let's move this to the right 2 units, 1, 2. So I'll just continue to move each point to the right 2 units. 1, 2. 1, 2. 1, 2. 1, 2. There we go. So my new graph looks like this. And there was no stretches or anything. Everything was just shifted to the right 2. So f of x is the graph in green. And the new graph looks like this. It's f at x minus 2. This moved everything right 2 units, this notation. Let's just say I wanted to move everything down 2 units. I want to take this graph and move it down 2 units. What would I do with my parent function with f of x? How would I change this to indicate that everything's being moved down 2 units? Well, you just simply write it like this. F at x minus 2. This would move everything down 2. So here's how I remember it. If the number's inside the parenthesis, it moves it left or right, and you think opposite. If the number's outside the parenthesis, it moves it up or down, and you don't have to think opposite. So this actually does move it down 2 units. So if I were to do this one, I would take each point and move it down 2. I'd take this and go down 2. I'd take this and go down 2, and so on, and then make my new graph. Let's say I wanted to take this graph here and move it up 2 units. How would I change this f of x notation? What do you think? I want to move it up 2 units. Try to write the new notation. Well, hopefully you're thinking this would be f at x plus 2, right? This would move everything up 2 units. So I take each point and move it up 2. Let's say I wanted to take this graph here and move it to the left 3 units. What would the new notation look like? I want to take this graph and move it left 3 units. Well, it would be like this. F at x plus 3. This would move everything to the left 3 units like this because it's inside the parentheses. So I'd go 1, 2, 3. 1, 2, 3, and so on, and then make my new graph. Now at the beginning, if you remember, we multiplied by 2 to vertically stretch it. What if I wanted to flatten this graph by a factor of 1/2? Vertically flatten it or make it appear wider. What would I do? Well, I'd do something like this. I'd go 1/2 times f at x. If it were written like this multiplication by 1/2 would flatten the graph vertically. It would compress it down. I mean, you would just take each y value here and take half of it. You can try that if you would like to. So in summary, when you multiply, it causes the graph to either vertically stretch or vertically flatten. And when you add or subtract, it's going to cause a movement up, down, left, or right, depending where the number is. And in a future video, I will show you how to combine these into more than one transformation. I mean, you could have something like this in closing. You could have something like this where it gets more complicated. Maybe something like this where you have more than one transformation. And I'll get to that in a future video. Well, I hope you found this helpful. Have a great day.